15 strange galaxies that challenge our science. How can galaxies exist before the Big Bang? Scientists are desperately seeking explanations for observations that show our old cosmology cannot be right. If we apply old standards, the galaxies observed by the James Webb Telescope should never have existed. But they are real. They are genuine. And we are witnessing a cosmic revelation that calls into question everything we previously thought we knew about the origin and development of the universe. If galaxies in the universe were so large and developed so early on, then perhaps we need to rethink how quickly matter was able to form, and whether we have understood the beginning of the universe correctly at all. John Mather. The 15 galaxies that the James Webb Space Telescope has discovered in the depths of space show structures that are far too old, far too large, far too developed to fit into the old model of slow cosmic evolution. Some of these galaxies contain billions of stars, are compact in structure, and even show signs of black holes. All of this should not be the case a few 100 million years after the Big Bang. The big question: how could these galaxies form so early? According to the standard model of cosmology, gas clouds would not have condensed enough until much later. Stars and galaxies should have taken billions of years to form en masse. But the reality in space does not conform to our scientific formulas. Scientific reactions. Some researchers speak of a major cosmological rethink. Others suspect previously unknown physical processes that could explain far more than just these 15 impossible galaxies. Still others see evidence of traces of an earlier universe. Could it be that the universe renews itself in cycles? The early cosmos was completely different from what we thought. Perhaps the James Webb Telescope has not only discovered new galaxies, but opened a window to a new reality where time, space, and origin no longer play by the rules we know. These 15 unexplainable galaxies could point us toward a direction we hadn't previously considered. Our universe may be much deeper, more mysterious, and more wondrous than we ever imagined. And we are just at the beginning of this discovery. What do we really know? It may sound paradoxical, but the more we learn about the universe, the more we realize how little we know. Modern science has made enormous progress. We can accelerate particles, observe distant galaxies, decode DNA, program artificial intelligence. Our formulas work, but they don't deliver absolute truth. Our technology functions, but it leads to more questions, not answers. Much of our knowledge is based on models that represent reality, but these models are not necessarily the truth. The limits of our understanding. Gravity is considered well described, but we still don't know what it truly is. Some theories even suggest gravity might not exist as we think. Dark matter and dark energy make up 95% of the universe, yet we've never directly observed them. Our standard models fail at the extremes. The Big Bang's true nature. Singularities. The interior of black holes. Consciousness. Science is not a collection of irrefutable truths. It's a method of asking questions, not always answering them. The James Webb Space Telescope, pushing boundaries. The JWST was developed to answer astronomy's biggest questions. How did the first stars and galaxies form? Are there habitable exoplanets? How did planetary systems develop? Key instruments. 6.5-meter primary mirror. Captures light that has traveled over 13.5 billion years. Near-infrared camera NIRCam. Detects faint objects invisible to other telescopes. Near-infrared spectrograph NIR-SPEC. Analyzes chemical composition of 100 objects at once. Mid-infrared instrument MIRI. Observes cold objects like dust clouds and exoplanets. Positioned 1.5 million kilometers from Earth at Lagrange Point 2, the JWST provides unprecedented clarity, revealing galaxies formed just a few 100 million years after the Big Bang. The problem of the Dark Ages. In traditional cosmology, the Dark Ages referred to the period after the Big Bang, before the first stars, when the universe was filled with neutral hydrogen, emitting no light. This era was thought to end with reionization, when the first stars ionized the gas, making the universe visible. But the JWST hasn't found this dark phase. Instead, it sees fully formed galaxies where there should be none. No evidence of gradual stellar nurseries. This raises serious questions. Was there really a dark age? Did galaxies form much faster than we thought? Is our entire cosmic timeline wrong? JWST Z14-0, the impossible galaxy. Discovered in May 2024, this galaxy existed just 290 million years after the Big Bang, is 1,600 light-years wide versus Milky Way's 100,000, yet is far brighter and more massive than expected. Contains oxygen, which requires multiple generations of stars. Why this changes everything. Oxygen should not exist in such a young galaxy. This suggests stars formed much faster, or the universe is older than we think. What's next? The JWST is just beginning to rewrite cosmic history. Future projects like the Square Kilometer Array (SK) radio telescope may detect signals from the dark ages, confirm if the Big Bang was truly the beginning. One thing is certain. Our universe is far stranger than we ever imagined. Subscribe now for more groundbreaking discoveries.